Okay, let's get started. Welcome to CS 228, Human-Computer Interaction. If you're not signed up for 228, now's the time to leave. No, you're all in the right place at the right time? Okay, we have 42 students signed up for this class, and this room says that it seats 42 people. I see 4 empty seats up here at the front, so maybe some people didn't make it today. That's fine. Everybody see the screen okay? Okay, awesome. So what we're going to do today is we're just basically going to do a lot of housekeeping, logistics, what you can expect from me, what you can expect from the TA, what we're going to expect from you, and if we have time, we will get into the interesting part of the course. As you know, obviously, we're here Monday, Wednesday, and Friday, 10:50 to 11:40. Somebody please remind me, there's a clock in the back there. Once I get going, I might forget. Please stop me 5 minutes early, and each of you is going to get to take home one Leap Motion device today. There's 42 of them sitting behind the screen here, so I think with 5 minutes, we should all be able to grab one and sign it out. So somebody remind me, we're going to stop at 11:35 today. Okay, all right, let's see, other boring logistics stuff. I'm Josh Bongard, you can call me Josh, that's fine. My email's up there. Office hours are sort of right after this class. My office is in Farrell Hall, which is on the Trinity campus. So if you have a short question, we can walk and talk from here back towards my office. If you have a longer question, you might want to walk over to Farrell for noon to 1, and then I also have office hours Tuesdays 4 to 5. Is there anyone here who cannot make either of those office hours? 1, 2, 3, 4. Anyone who cannot make either of those times? Okay, I will put up my total fall schedule, so if you need me, we might be able to find a time to meet outside of my office hours. Yeah? Okay. Obviously, though, first line of defense is the teaching assistant. Owen Marshall is the TA for this class. He's an undergraduate. He took this class last year, so he will know the pain that you will be going through. There's Owen's email, and on Blackboard, I put up his office hours. I don't remember them off the top of my head, but he will hold office hours, and he's going to hold them in 332, which is the computer lab up on the 3rd floor. That worked pretty well last year. If it gets too noisy in there during his office hours, we might find another time and another place. We'll see how things go. Okay. And then again, there's lab meetings available for you in VOTI 369, and I saw some computer labs down here. How many of you have a laptop? Okay. How many of you are going to be using lab computers, which is fine if you do? Okay. All right. We'll talk about that. Okay. So before we go on with logistics, just to keep things interesting, I want to try and do a live demo. We'll see how well this goes. The heart and soul of this course is going to be a series of programming projects that you're going to be doing with the Leap Motion device. As I mentioned, you'll be getting one at the end of the class today. When you get this box and you take it out, you will see something that looks like this. You plug it into your computer. And let's get this going here. Okay, bear with me a second here. Okay, so once you have your device here, it sort of sits on your desk, and you can then wave your hand above it, and the Leap Motion device is meant to capture the three-dimensional position of every bone in your hand. You can see it's a little jerky because my hand is shaking, so I'm going to put this down on the desk, and here we go. Okay. It can capture 0 hands, 1 hand, or 2 hands. How the Leap Motion device works is basically there are two cameras in here. You might not be able to see the two red lights from here. These are just infrared LEDs. So it's basically capturing reflected light. And there's some very sophisticated machine learning that is going on inside the Leap Motion device, which is taking an array of pixels, which is reporting the amount of infrared light that's arriving at the camera, and inferring, as I mentioned, the X, Y, and Z position of every bone in your hand. That's what the Leap Motion device does for you. You're going to be doing in this class a series of weekly programming projects, and we'll talk in a little more detail about the first project today. Your task is to then take the three-dimensional positions of every bones in the hand and wrap that into an increasingly sophisticated program that you're going to be using to teach your roommate or your boyfriend or your girlfriend or a friend how to learn American Sign Language. So the Leap Motion device takes camera data and turns it into coordinates for you. You are going to be writing some software that grabs all of those coordinates and tries to figure out, is the person trying to sign 0, 1, 2, 3, M, N, and so on, and broadcast that information back to the ASL learner. Any questions so far? Okay, that's the Leap Motion device. Let's get back to logistics here. As I mentioned, the Blackboard is going to be our main point of contact for all material and deadlines and submissions and all that sort of thing. I'm sure you're all familiar with Blackboard. You'll see that I put up a syllabus for the course, so let's just spend a couple minutes going through the syllabus so that we're all on the same page. Okay, I think I've talked about all this so far. There's Owen's office hours, Wednesday and Thursday, 2:45 to 3:45 p.m. Here's the little blurb for the course. It's a little bit dated, but it sort of gets to the point of things. In this course, we're going to be talking about the design of user interfaces, how to implement them, and how to evaluate that they're working well. You're going to be creating some ASL educational software, and all you're going to do with your user is put this on the desk in front of them and say nothing else. And you're going to be assessed on how well your software teaches the person that they need to do this, not this, not this, that if they do this, that this thing, whatever it is recognizing their hand. A little bit later, it's going to recognize that they are or are not signing the number 0, and so on. How do you actually evaluate that that's working well? Your code might run perfectly fine with no bugs, and 9 out of the 10 users who've never seen this before, when you start up your software, they look at it and they grab it like this. Your software works perfectly well, but in terms of a user interface, it's failed completely. That's what we're going to spend most of the time talking about in this course. Okay, so how do you design such an interface that's intuitive and so on? How do you implement it? How do you evaluate it with lots of different users? And we're going to start by talking about traditional interfaces like browsers and so on, and we'll get into increasingly complex and more exotic electronic equipment. Topics that we'll touch on are interface design, human factors, cognitive psychology. So if you're trying to design an interface that's intuitive for a person, the moment a person looks at the screen or looks at this, they have a whole bunch of hardware up here, and they have expectations about how they're expected to interact with the software or the hardware. So we're going to spend quite a bit of time in this course talking about psychology, right? When someone looks out at the world, what do they expect to see? When somebody interacts with the world, what do they expect to happen? When they interact socially with someone else, how do they expect that person to react? All of those expectations about the physical world and the social world, users bring it to bear on hardware and software, often without them realizing that they are. What are those expectations, and how do we design interactive technology to make sure to support those expectations rather than frustrate them? Okay, so we'll talk a little bit about cognitive psychology. I do research in robotics, so I had to find a way to shoehorn robotics into this course somehow. We'll get to robots a little bit later. We'll talk about wearable technology, augmented reality, Pokemon Go, Google Glass. We'll get to all of that fun stuff in a little bit. Again, this course includes a significant project. There's no midterm. There's no final project. You're going to be developing software for this. And then the final project is going to be you using your ASL educational software to teach people ASL. Okay. All right, when you finish this course, what should you be able to do? You should understand how HCI is different from traditional software engineering. How do we go about trying to design software that's not just bug-free, but software that people actually want to use? Understand the challenges and implications of putting the person first. So we're going to spend a lot of time already, as I mentioned, thinking about how people think. I've already told you that the Leap Motion device takes a camera image and turns it into the coordinates of the bones in your hand. You are then going to be taking that and trying to write software that allows your computer to recognize, did somebody sign one of the gestures in American Sign Language? We need to think very carefully about how people might try and sign a sign from ASL. Who heard me give a pitch for this class in CS50 last year or the year before? Okay, a couple of you have heard this already, so if you know the answer to this, don't answer. If you've heard this for the first time, you can answer. There's going to be a lot of challenges in trying to put humans first when you develop this ASL software. What might some of those challenges be? Aside from getting the code to run without bugs. I think you were in my CS50 class, right? Okay, no cheating if you know the answer to this. Everyone put up their hand for a second. Raise it high so everyone in the class can see it. Okay, now with your hand raised, this might be hard for people in the front, turn around and look at all the hands in this room. Okay, you can put your hands down. What can you tell me about what you just saw? That's going to make things tricky as we go. All hands look different.
Some people use lefties.
Exactly. Did anyone notice how many lefties just put their hands up? There's a few. Okay, lefties, please identify yourself if you're here. We have 1, 2, 3, 4, 5, 6 lefties this year. That's good. Okay. So putting people first, everybody's different, right? Everybody's hands is different. That's great. When you start to write your machine learning code to try and recognize ASL, it's not going to help you to say people's hands are different. Different how? So we know that recognizing this isn't always going to work for someone who's going to sign 0 like this, right? It's going to be that's going to matter. What else, aside from righties and lefties, is going to matter?
Amputations.
Yes, some people may not have a right or a left hand, or both. What else? What else differed among the hands that you saw?
Just like the different style in which they might like rotate their hand or
Absolutely, right? So if you write your code and it flashes up a big digit 0, which means try and sign 0, someone does this, someone does this, someone does this. Those 3 different ways of signing 0 are very different in terms of the Leap Motion device. Some are easy to recognize, some are not. Turns out actually this one is easy, this one is very hard. Why? Now we're thinking not so much about the human, but we thought about humans. They might sign it at different orientation. We want to work back from the human to the interface. Why might Leap Motion device have a harder time recognizing this than recognizing, actually it should be like this, I think. Why is this harder than this?
Because the 3 fingers below it might get in the way of the active sign.
Absolutely, right? So the 3 fingers are occluding the fact that my thumb and forefinger are trying to sign 0. Do you think a user who's never seen a Leap Motion device is going to know that? Absolutely not, right? So already, when you start to think about your system, you're going to have to signal or advertise to the user certain things, right? Like don't grab the leap motion device, don't put your hand on top of the leap motion device, hover it somewhere about a foot above the device. If you're going to sign things, make sure that the leap motion device can see it, right? Okay, let's think a little bit more about trying to put people first. So righties and lefties matter, orientation is going to matter. What else might matter? John?
Hand size.
What's that?
Hand size.
Hand size is going to matter. It's going to matter particularly for this class. One of the things we're going to talk about in HCI is some of the surprising repercussions of cultural and social context. So think about this particular class that has to do with hand size. What's different about this class than some of the other UVM classes you might be taking? What's different about us? Yes?
We're all computer science majors.
You're all computer science majors, yes. What's the difference between a lot of the CS classes you take and a lot of the non-CS classes you take?
There's a lot of males.
There's a lot of males, right? Look at the gender ratio in this class. What do you know about male and female hands? Generally speaking.
Guys have bigger hands.
Guys have bigger hands, right? So we're going to create in a few weeks, a data set that is collected from all of you signing above your leap motion devices. So in that combined data set, we're going to have mostly right hand gestures. We're going to have mostly male-sized hands. Machine learning algorithms tend not to do very well with the minority data. Left to its own devices, most machine learning algorithms will say, 80% is good enough, I'll just ignore the 20%. Okay, let's keep pushing on this for a moment. I told you that the leap motion device has infrared cameras and it detects reflected infrared light. What else might it have a harder or easier time recognizing? We talked about righties and lefties, males and females.
Watch or something?
Absolutely. Any jewelry that is reflective, it might be an issue. What else?
Difference in skin tone.
Skin tone makes a difference as well, right? Look around at your peers. Think about that as you're designing your interface. All of these things are the heart and soul or the black art of HCI, right? In this course, it's not so much about writing code that works correctly. It's making sure that you write code that takes into account the diversity among your user group. Have you thought carefully about who's going to use it? And have you come up with innovative hardware and or software solutions to handle the diversity in your targeted demographic? Okay. Obviously, you're going to gain a lot of practical experience designing these kinds of interfaces and implementing them. And we're going to spend quite a bit of time trying to think about the likely near-term future of interactive technology. Leap motion devices are here. Google Glass is kind of here. Drones are coming. Autonomous cars are coming. Augmented reality, virtual reality. These are all very different kinds of interactive systems. Hopefully the things that you learn in this class, if you go out and work in this particular industry, will help you think carefully about what happens when half the population is walking around and looking at the little camera in their glasses. Right? It's going to be an interesting world. Okay, course materials. There's no required textbook for this class. The first third of the class, more or less, I'm going to draw a few chapters from Designing the User Interface by Schneiderman et al. You can go and get a copy of the book if you like. It's not in the UVM library. I will put one on loan. It's not in the bookstore. I'll put one on loan in the library. I haven't done that yet. But I will put all of the readings up in Blackboard anyways. Some optional reading will be drawn from a book I wrote a few years ago with my colleague Rolf Pfeiffer. Again, all of the readings will be posted directly to the schedule and the syllabus, and you can find them there. Okay, I also put up the lecture slides on Blackboard. Please download, either print them out and bring them in dead tree form or electronically on your devices. What you'll see as we go forward is a series of PowerPoint slides, and from time to time there'll be a big red, empty red rectangle. That's a signal to you that you're supposed to annotate something inside that rectangle. I know how PowerPoint eyes can glaze over, so I will try and not kill you with PowerPoint. They're just there as a template for you to annotate as we go. If you like to do that pen and paper, that's fine. If you want to do that electronically, that's also fine. But I'm expecting when you're in class, you're annotating the slides as we go. You won't have to do that today. We'll start that on Wednesday. Okay, as you might have noticed, I started taping the lecture at the beginning of class. When class finishes and I get back to my office, I'll push it to YouTube and I'll put a link to the video lecture into the schedule. So if you miss class or there's stuff you want to go over again, you can go and have a look at the video lecture slides, the video lectures. I taped the first 11 last year. They're already up there in a YouTube playlist. I'll create a new playlist for this semester and I'll fill in the videos as we go. Okay. Let's see. There is an online multiple choice test after each lecture. It's due at 11:59 p.m. the day of. So your first quiz is due tonight by 11:59 p.m. Again, when I get back to my office, I'll make the quiz live on Blackboard. Shouldn't take you more than about 2 minutes if you came to class and did most of the reading. It's just there as a prod to make sure that you keep up with the lectures and the reading material. Sound good? Okay. Let's see. Software, as you probably figured out, this is a pretty programming intensive course. Who has not programmed in Python before? Okay, a couple people. If you have not programmed in Python before, I highly recommend Codecademy. It's a browser-based Python tutorial. For those of you that haven't programmed in Python before, get started on that immediately. Everything in this course is going to be done in Python, so make sure you've brushed off the rust flakes from your Python programming. Okay. We are going to be making use of 4 Python packages in this course. NumPy is numerical Python, which allows you to manipulate vectors and matrices. We're going to be doing quite a bit with NumPy. Matplotlib is a visualization package. This is going to be used to project all the graphics to your user for your ASL system. Scikit-learn is a machine learning package for Python. We're going to make use of that in a few weeks' time. And Pygame is a way to sort of create fun graphics that you can add on to your ASL system as we go. Forgot to put up here, there's actually a 5th Python package, which is the Python SDK or software development kit for the Leap Motion device. So in the first programming project, which we're going to talk about shortly, you're going to be using the Leap Python package and Matplotlib, just those 2 this week. Okay, grading participation is worth 5%. At the beginning of every class, I'll pass around an attendance sheet. So just give it your signature there, pass it on to the person next to you. If you come in late or you don't get the sheet for some reason, make sure you come up to the front at end of class and add your name to it. You can miss up to and including 3 classes. If you find that you're missing more than 3 classes, come and talk to me and let me know. Let me know why. Okay, as I mentioned, these very simple quizzes at the end of class. We have about 30 classes. They're worth 1% each. Every week, you're going to be submitting one of these deliverables or these programming projects with the Leap Motion device. Each one is worth 5%, so you can see where the bulk of your grade is going to come from. These weekly programming projects are cumulative. They build on the one that you did the week before. So make sure not to fall behind in the programming projects. If you don't finish one and you don't submit it, obviously you don't get the 5%. You're going to have to finish it anyways the following week so that you can implement the next deliverable. Once the first 10 weeks of the semester are up, you'll have done your 10 programming projects, and you will have a functioning system that recognizes ASL signs from pretty much everyone here in the class, because we're going to use a machine learning algorithm to train on data from everybody's hand in this class. That's what you'll have at the end of the 10 weeks. The remaining 4 weeks, you're going to be turning that simple recognizer into a full-blown ASL educational system. It's up to you how you want to do that. We'll talk about that later. Any graduate students here? No grad students this semester? Okay. Let's see. Student responsibilities, late policies. You're docked 25% if you submit 1 day late, 50% on the second day. After that, you don't need to submit. You can cooperate and help each other, but obviously you're going to be working more or less alone on the 10 programming projects and then on your educational software. It's super easy to cheat on the 10 programming projects. You can probably get the code by now off the web somewhere or from someone else in the class. If you do, you're going to be completely lost in the last 4 weeks about how to turn that simple recognizer into an ASL educational system. Your choice. Okay, we talked about participation. Let me know if you have any exceptional needs. Okay, let's go to the schedule now. So that's the syllabus, which is up here on Blackboard. If you click on course materials, you'll see at the moment there's a schedule up here. We will start with this schedule at the beginning of every class. Let's wait for it to format this for... Okay, so here's the schedule. Here's today. Here's a link to the PowerPoint slides for the first lecture, which we're probably not going to get to today. That'll be on Wednesday. That's fine. There's the required reading for today. The quiz for tonight will draw on what I've said today and from this first chapter. Some optional reading here, bad designs. It's great to have a look at bad design to get a good feel about how to do good design. That's completely optional. Nothing on the quiz will come from the optional reading. You can see that I've already put up the first deliverable. The first deliverable will be due next Monday at 11:59 p.m. So you got a little over a week to do the first deliverable. For those of you that are learning Python, this is going to be a pretty busy week. Okay, so we've got about 10 or 15 minutes left. So I want to just walk through the first deliverable with you. Okay. All of the deliverables, as you'll see, are a set of step-by-step instructions that guide you through the programming of the Leap Motion device. What you're going to be doing in, let's try and, can we see this a little bit better? Okay. What you're going to be doing in deliverable 1 is establishing a very basic feedback loop between the user and the Leap Motion device. Deliverables 2 through 10 are going to just be complicating this feedback loop. So make sure in this first deliverable that you understand this feedback loop so that you can add stuff to it in the weeks to come. Okay, so how does this work? You turn on the Leap Motion device. The user hovers their hand over the Leap Motion device. As I've already told you, the Leap Motion device outputs three-dimensional coordinates of all the bones in the hand. You're going to throw away all the coordinates except the X, Y, and Z position of the tip of the index finger. And that X, Y, and Z coordinate is going to move a black dot around the user's screen. So at the end of deliverable 1, when you run your code, you should be able to hover your finger over the Leap Motion device and move a circle on the screen. You see the dot moving, and that influences how you move your finger, right? It's just that simple. Okay. So how does this work? Well, I've broken this into 3 parts, 1, 2, 3 here. what you're going to be doing is implementing these 3 parts in turn. At the end of each part, you're going to shoot a short 5-second video. You can just do it with your phone of your screen. No points here for video quality. You're just demonstrating to us that you were able to implement that part. So you're shooting 3 5-second videos. You're going to push those 3 videos to YouTube, stitch them together into a YouTube playlist. And then when you submit next Monday, all you do is submit a URL that points to the YouTube playlist. The TA will just go and watch your 5-second videos. Yes, you got part 1, part 2, and part 3 correct. It's the same for all the deliverables. You're not submitting any code. You're not submitting any PDFs. You're only submitting a URL that points to a YouTube playlist that demonstrates to us that you implemented this week's deliverable correctly. Sound good? Okay, so step 1 is pretty straightforward. Here's my video. This is just demonstrating that I've plugged in my Leap Motion device. This program that's running here, the visualizer, it comes with the Leap Motion device. So this video is just demonstrating that you're able to download and run Leap Motion fine on your machine. It should take you 30 seconds. Okay. Okay, so there's no real coding in that one. In step 2, you're going to be using the matplotlib Python library, which is the visualization part. So you're going to put your Leap Motion device to the side. You're going to write some matplotlib code in Python that just draws a black dot and moves it randomly around the window. Pretty straightforward. So that'll just get you familiar with the visualization side of things. And then in step 3, you're going to be connecting your Leap Motion software with your visualization software. So now when you move the tip of your index finger, it moves the black dot. Okay, any questions so far? Pretty straightforward. The biggest challenge this week, for those of you that know Python, is going to be installation headaches, right? We have, how many people are Mac people? How many people are PC people? How many people are Linux people? Okay, so we got an even split between Mac and PC, a few Linux users. You're going to get a Leap Motion device. Some of them are this year's Leap Motion devices. Some of them are last year's Leap Motion devices. We've got different operating systems. Luckily, we all have one version of the Leap Motion SDK that you're going to download from their website. So we're going to have lots of different combinations and permutations of hardware and software. Some of you, installation will take 60 seconds. Unfortunately, for some of you, and I don't know which ones you're going to be, installation is going to be more painful. Nothing I can do about that. All I can do is urge you that when you get your Leap Motion device today, make sure you do today's quiz and then start working on Deliverable 1. Once you get all the software installed, things will go a lot smoother on Deliverables 2 and onward. Okay. Yes?
I went to the page where you download the SDK.
Yes.
And it says sign in.
Yes, you might have to create a user account for
Okay,
the
so
Leap.
it's the free user account.
Yeah, just go ahead and create a user account. I think there's a download link there for Orion, which is their attempt to integrate Leap Motion with Oculus Rift. Unfortunately, I don't have an Oculus Rift for all of you. We're just doing V2, which is version 2 of the Leap SDK. All right, maybe next year. We'll see. Okay. Okay, so let's go back to Blackboard for a minute. I walked you through the syllabus. We had a look at the schedule. You can see now that there's a link that's live for the first deliverable. There's all the instructions for the deliverable. When you've created your YouTube playlist, come back to Blackboard, click on Deliverable 1, and you'll see here it says text submission, write submission. Just click on that and just type in or copy and paste your URL in there. That's it. Any questions? And that's due next Monday at 11:59 p.m. We're all good? Okay. We got about 10 minutes left, so let's go back to the schedule for a moment. Okay, I've broken the course material up into 5 sections. The first section obviously is kind of overview and introduction, what actually is HCI and how does it differ from software engineering and all the other computer science things you've learned so far. The second of the 5 themes we're going to tackle is design. How do you actually sit down and think about designing an ASL educational system that uses this device that most of your users have probably never seen before? How do you actually go about designing and then implementing such a system? September 19th and the 21st, I will not be here. Jeff Springer is a former student of this course, and he is now the CEO of Zemo, Zemo Corporation. They're developing robotic educational games. They're going to be publicly launching their game on Steam this year. So they're in sort of their alpha testing phase. You are going to be some of the alpha testers. So you're all going to get a copy of Zemo on the 19th, and Jeff is going to be here to introduce you to Zemo, and he's going to take you sort of behind the scenes of his company and sort of show you how they developed this educational game, which is maybe more sophisticated, but not that different from what you're going to be doing in this course. Okay. All right, the third of the 5 themes we're going to be tackling in this course is cognitive psychology, right? The minute someone sees a novel piece of software or a novel app coupled with a novel piece of hardware, they bring a lot of expectations to bear on that system. They're going to expect it to have certain features. If it's something that looks anything like a browser, they're going to expect something like search up here, something like a home icon up here, and all sorts of other expectations. Where do those expectations come from? It comes from our decades of experience of interacting with the physical world and interacting with the social world. We'll talk a little bit about that. Theme 4 of 5 I call looking outward. Most computer technology up until the last few years has been pretty standard, right? Something projected on a screen, you got a mouse and a keyboard, and away you go, right? In the last few years, computers have started to thread their way into the everyday fabric of our everyday lives. Most of you probably have one of these sitting in your pocket or on your desk or in your knapsack, right? Computers are now out here in the world with us. When they're out here in the world with us, they are interacting with the world. Your computer is interacting with the world in a very different way than a traditional computer sitting on your desk, right? How does a computer deal with the real world? So we're going to talk about looking outward and all the different kinds of technologies that exist and those that are coming. And the 5th and final segment I call looking inward. So computers are coming out into the real world, but they are also coming inward towards us. So virtual reality, augmented reality. We'll talk about wearable technology elsewhere in the course, and cyborg technology. So cochlear implants that allow the deaf to hear, retinal implants that allow the blind to see already exist. Some of you have seen 3D printed prosthetic arms, right? Our computers are actually physically entering us, and they are interacting with us in very intimate and unexpected ways, right? So think about human-computer interaction taken to the limit. You have a device that actually becomes part of the human being and is interacting directly with your nervous system. There's some interesting challenges there. Okay, so that's the schedule, and again, as I mentioned, we'll start with this at the beginning of every class, and I'll upload slides as we go. So here's the lecture slides for today, which we'll just start on today, finish tomorrow, and lecture slides for Wednesday as well. So on Wednesday, either bring these lecture slides in electronic format or print them out for annotation. Okay, so we have 5 minutes left, so let's start on lecture 1 here. Let's start with a little bit of a history lesson here. It's a potted history of computers. I picked a few computers here. Which computers do you recognize here? iPads, pretty obvious. How about the gray one in the top center there? Someone's nodding their head back there. What is it?
I just remember dial-up.
It did have a dial-up modem. That's the Commodore 64. That was my first computer. I'm old, but I'm not that old. That's the ENIAC back there, one of the very first computers. We're not going to do a history of computers. What I want you to pay attention to here is think about all the ways in which people interact with these computers have changed over the years, right? We go all the way back to the ENIAC. The way of interacting with the ENIAC was plugging in and out plugs or feeding in a deck of cards. It didn't take too long for the mouse and keyboard to arrive, which we still more or less have. Then we had the touchpad. Now we have the touch screen. The way in which we interact with computers has changed greatly over the history of computers. And again, the rate of change is increasing, right? The diversity of computer technology that's out there is increasing. So there's our Leap Motion device. There's Google Glass, which was made public for use about 2 years ago. Has anyone seen anyone walking around with a Google Glass? A couple people, but not many probably. Why not? Anybody know what happened to the Google Glass in the last 2 years or so?
Did they scrap the project?
Why did they scrap it's on? Google says it's on hold indefinitely, so they haven't scrapped it. Anybody know why? Why would you possibly scrap such a world-changing technology?
Were people upset about the privacy and stuff?
Massive privacy concerns. There was the beginnings of a huge amount of legislative action. Google said, wait, let us rethink this a little bit, right? There are huge political and cultural implications to HCI, right? And again, something to think about. Here's a cochlear implant, which we'll talk about later. Here's a 3D prosthetic arm. This is where we're heading. And we've already seen how you have to think kind of carefully about who is going to be using this. And when you start thinking about who is going to be using this, it changes your thinking about how to write code for this, right? You may or may not be working in this industry. You may or may not be working directly on the hardware. You probably will be writing software for pretty exotic computer technology in the not too distant future. Again, my hope is that you take away a lot of lessons from this course that make sure that the software you write for this HCI interactive technology is inclusive of everyone who wants to use it and not exclusive. Okay, I think this is a good place to pause. You come and collect a Leap Motion device. You'll notice there's a number on the box. Sign your name next to the box. You got a quiz due tonight, and I'll see you on Wednesday.